Hello, everybody. Welcome to United Leukodystrophy Foundation's Ambassador Program webinar. Today's title is Welcome to Family Planning as a Carrier. And what an important topic to have, knowing that this is a genetic disorder that the leukodystrophies all encompass. So I think it's important for ourselves, for our loved ones that might be carriers, to get as much knowledge behind us if we are planning a family. So I'd like to welcome our guest speaker. Her name is Julie Cohen. She's a genetic counselor and she specializes in neurogenetics and neurodevelopment disorders. So what a perfect candidate to have to speak with us today. And she hails from the Kennedy Krieger Institute. So welcome, Julie, and we'll sit back and relax and enjoy your presentation.
Yes, thank you for that introduction, and thank you for the invitation to speak today. I appreciate everybody taking a little bit of time out of their Sunday afternoon or maybe late morning, depending on where you are. I'm on the East Coast, to listen into this talk. So a little bit more background about me. I am, as you said, a genetic counselor, and I've been working in the field for just over 15 years now. And for almost my entire career, I have worked at the Kennedy Krieger Institute, and specifically one of the centers that I support is the Moser Center for Leukodystrophies. Many of you are probably familiar with Kennedy Krieger and the Moser Center as one of the expert centers in leukodystrophies around the world. And I'm honored to be able to work there and to have, over a decade of experience working with families affected by leukodystrophies. Okay, now is the drum roll, please. Let's see if I can share my screen, go into presenter mode and share my screen. Okay, fingers crossed. Let's see if I can do it. Here we go. Presenter mode. This is where I get nervous. Here we go. Okay, I'll start by sharing my screen. Okay, share, and now I'll go into presenter mode. There we go. Yes, folks can see? Oh, I did it. Wonderful. Okay. So today, of course, we're going to talk about what it means to be a carrier and talk about the various reproductive and family building options that are available to you. I like to start off by talking about what does it mean to be a carrier? What does that word mean? So, and in general, a carrier is a person with a genetic variant who's at risk to have a child with a genetic condition. The term carrier implies that the individual themselves is not affected with the condition. We'll talk about different inheritance patterns in just a minute. I'll say that it is true for carriers of what we call autosomal recessive inherited conditions, that carriers do not show symptoms of the condition. For X-linked disorders, carriers may have symptoms, so it can impact them in that way, and we'll talk a bit more about that. But I also want to acknowledge that even if a carrier doesn't experience any physical effects of the condition, there can be a big impact emotionally as well as psychologically. So I am going to give you a very quick review of key genetics things. This is what I call everything you need to know about genetics in 30 seconds or less, maybe a minute. So I like to use the analogy that our genetic information is like a giant cookbook to make a person. And genes, those are the recipes within the cookbook. And DNA, that's the letters that spell out our recipes. Chromosomes are the chapters that organize all of our cookbooks, and each of our recipes is the instructions to make a protein, like the finished product there. So we have an enormous amount of genetic information. We have 20,000 genes, and there are over 50, over 100 different leukodystrophies. And so, as you all know, of course, what leukodystrophies are, but the point is that they're each caused by changes in different genes, and there can be different inheritance patterns. You'll hear me today use the word variant. This refers to a specific typo in the recipe. So the specific DNA letter change, that's the cause of a particular genetic condition. We used to use the word mutation, but we're getting away from that term and we say variant. So any specific leukodystrophy is caused by changes or variants in a particular gene, but each individual with that specific leukodystrophy, they may have a different variant or DNA letter change. All right, so like I said, our genes are organized into chromosomes that are like the chapters, and we have 2 copies of our cookbook, 2 copies of every chromosome and every gene. We get 1 from mom and 1 from dad. Another word you'll hear me use today is autosomal. So an autosomal gene, that's a gene that's on the numbered chromosomes, and everyone has 2 copies. Then there's genes on the X chromosome, and people with 2 X chromosomes, females, have 2 copies of that gene, and males have only 1 copy of the gene. I also want to acknowledge here that that our chromosomes don't determine our gender identity. So I will be referring to people with 2 X chromosomes as female and those with an X and a Y as a male, just for the sake of simplicity. Okay, so now let's talk about the different inheritance patterns: autosomal recessive, dominant, and X-linked. An autosomal recessive condition, this is a condition. It's caused by a gene on the numbered chromosomes, so everybody has 2 copies. And for an autosomal recessive condition, it only manifests or shows up with symptoms when both copies of the gene are altered, have a variant. And generally, of a child with a recessive condition, typically both of their parents are carriers. And carriers, like I said, they don't show symptoms. If both members of a couple are carriers for the same recessive condition, in each pregnancy, there's a 1 in 4 or 25% chance to have a child with that affected with the condition. And there's a 50% chance to have a child who's a carrier and unaffected, and a 25% chance to have a child who is unaffected and not a carrier. And there aren't any differences in those chances based on the sex of the parent or the sex of the child. Everyone has many, many genetic variants, and we're all carriers for a couple different recessive conditions, but it only matters if both members of the couple are a carrier for that same condition. Then let's talk about autosomal dominant inheritance. So a dominant disorder, this is a gene that's on the numbered chromosomes, so everybody has 2 copies. But with a dominant disorder, it manifests or shows symptoms when 1 copy of the gene is altered by a variant. So in other words, you need 2 working copies of the gene to not have the disorder. And I know today we're talking more about carriers who are not necessarily affected with a condition, but I'm mentioning dominant here as a comparison, but also because the reproductive options I'm going to be talking about are applicable to those with dominant conditions as well. So for a person who's affected with a dominant condition, in each pregnancy, it's a flip of the coin, a 50% chance that the child would inherit the variant and have the condition, and a 50% chance that they wouldn't. And again, there's no differences depending on the sex of the parent or the child. Occasionally, with dominant conditions, it can also happen with X-linked conditions as well, that the genetic variant doesn't come from either parent. It happens new in that individual. And this can be a surprise to some people because we don't think about that, right? When we think about a genetic condition, you assume, oh, that's inherited. But it's actually not. Sometimes a genetic variant can happen new, either in the egg or the sperm that created a person. Nothing external that causes that. It's just by chance, sort of like a random typo if you were copying your cookbook. So for parents or a person who has a child with a de novo variant causing a dominant disorder, there's a very low chance to have another affected child. It's not 0 due to the possibility that the variant is present just in the mother's egg cells or the father's sperm cells. We call that germline mosaicism. That's probably a 1 or 2% chance. And now let's talk about X-linked conditions. So a male with an X-linked condition, so a male who has a variant in a gene on the X chromosome, will always show symptoms of the condition. They'll always be affected. Females have two copies of that gene, so they have a backup copy. So females who have a variant in one copy of their gene may not show any symptoms, but they could show symptoms depending on the disorder. So as an example, X-linked adrenoleukodystrophy, which is probably the most common leukodystrophy on the X chromosome. Females often show symptoms later in life, but not in childhood. There's in the X-linked community, there's sort of a discussion or movement to should we change the language that we use? Because when you say a female carrier, it implies that they don't have or never will have symptoms, and that can be harmful in some way, sort of minimizes the experience of those women. Moving towards the term to just say female with whatever that leukodystrophy is, female with ALD. The more technical term that would say is a female heterozygote. That is another way of saying that a person has a variant in one copy of the gene and the other one is normal. So a man who is affected with an X-linked condition, all of their daughters will be carriers because they only have one X chromosome. So if they pass on that one X chromosome, that offspring is going to be a female and she'll be a carrier. We call that obligate carrier. But none of his sons would be affected because his sons are going to inherit his Y chromosome. That's why they're male. And a presumably normal copy of the other gene, of the gene on the X chromosome. For a woman who is affected with or a carrier of an X-linked condition, there's 4 possibilities in each pregnancy. There's a 25% chance of an affected son, 25% chance of a daughter with the gene variant who could be an unaffected carrier or affected later on. And then a 50% chance to have an unaffected child of either sex. An unaffected son or a non-carrier daughter. For all of the inheritance patterns, I've given you percentage chance, 25% chance, 50% chance, but that chance is the same with each pregnancy. So it's not like, as shown here in this diagram, that if you have 4 children, it's going to be one of each possibility. It really is just a flip of the coin. Another thing to add is that for some conditions, I'm going to use ALD, adrenoleukodystrophy, as an example. For some conditions, the type of symptoms, the severity, and the age of onset could vary even among people in the same family who have the same variant and the same diagnosis. So with a genetic test, we can determine whether or not that person is at risk to show symptoms, but we may not. We usually can't predict what is that going to look like for that affected person. Those are the 3 or 4 inheritance patterns. Now I'm going to transition to talking about reproductive options. So you are a carrier for a leukodystrophy or you're affected with a leukodystrophy and you want to have a family. What are the options if you want to avoid passing the condition on, reduce the chance of having a child who's affected with the condition? Now, these are the 4 options that I'm going to go through. But I want to acknowledge, of course, that this is always a personal choice, and a person is not obligated to do any of these. It's a personal choice. It depends on your values, what's most important to you. It may depend on what are the treatment options for that leukodystrophy, or how is that leukodystrophy expected to impact one's life. So starting with PGT, this is the most high-tech of the options. So PGT is genetic testing of embryos that are created through IVF, in vitro fertilization. And doing this allows selection of embryos that do not have or are predicted not to have that genetic condition. This is a high-level overview that you take the eggs and the sperm, and they create embryos, and then you're going to biopsy or take cells from each embryo and perform a genetic test. And then you'll know which embryo what their status is. Are they predicted to be affected, a carrier, unaffected? And then you can select which embryos to use for transfer to start a pregnancy. So I'm going to start by talking about or giving an overview of what's the process of IVF. And what would this look like if you and your partner were to go through this process? Before you do IVF, it's important to have tests, right? So your doctor, we call that a reproductive endocrinologist. That's the type of doctor who treats people undergoing IVF. They are likely going to do tests looking at your baseline fertility, your hormones, your semen, your sperm quality, your egg quality. That's for any type of IVF. When there's a genetic condition at play, it's also necessary to do a genetic test of that person because you do need to know your specific gene variant in order to take advantage of the PGT, the IVF and PGT, or the prenatal testing that I'll talk about in a couple minutes. So once the couple is good to go to start the process, the woman undergoes what's called ovarian stimulation. And this is to stimulate her body to produce multiple or many eggs. And this involves medications that some of them are injectable, injections, hormones, and some are oral medications. And over the course of this period of ovarian stimulation, she's monitored very closely by her doctor with blood tests and ultrasounds to make sure it's all going well, to make sure she's not developing too many eggs. At the appropriate point in time, when the eggs appear to be at the right stage, she will have an egg retrieval. This is a minor surgical procedure performed as an outpatient under light sedation, and it's not any cutting through the abdomen. They do it through the vagina. And there they retrieve or they take out as many eggs as they can. And in any one IVF cycle, it is likely that a woman is going to have multiple eggs. The number of eggs, there's a variety of factors that influence that. One factor is age. As women get older, they may have fewer eggs, and then just other fertility factors. So they've retrieved the eggs, and now those eggs are fertilized by sperm. So the male partner provides the sperm sample, and then under the microscope, they actually take each individual sperm and fertilize that egg, and they let that early embryo develop in culture. That's what in vitro means, in a dish, if you will, or in a lab, to develop for about 5 or 6 days until it reaches a stage called blastocyst. Now, in typical IVF, that would be it. They would choose 1 or 2 of the best looking embryos to transfer to the woman to start a pregnancy. But when you're doing PGT, so that refers to the genetic test part of it, before the embryo transfer, so at the blastocyst stage, they biopsy the embryos. Now this is wild. Okay, so this is a picture actually under the microscope. This is showing a blastocyst. This is a couple hundred cells big, and these are the tools they use to take off a few cells from each early embryo. It is incredible that this can even be done, and also remarkable that it doesn't damage the embryos. So a few cells from each early embryo are removed and sent to a specialized genetic testing laboratory. Now, the genetic testing part of it takes a few weeks. So all of the embryos, once they're biopsied, are cryopreserved, frozen, flash frozen. And this also doesn't damage the embryos. And so those embryos are frozen while you're awaiting the genetic test results. And that may take a couple weeks. And once the embryo testing is done, your doctor will get a report that says, okay, embryo A, C, F, and G are unaffected. Embryo B, what have you, are affected with the condition. And then you and your doctor would decide how many embryos you want to transfer per cycle. It's usually 1 or maybe 2. And once you know which embryos, then in a subsequent, it's not a full IVF cycle, where you usually don't have those injectable medications again, but there is a period where you take some oral medications just to get your uterus ready to accept an embryo. The embryo transfer happens, it's also an outpatient procedure, but you're not sedated, it doesn't hurt at all. So transfer 1 or 2 unaffected embryos, and then everybody crosses their fingers and their toes, and you wait and see if a pregnancy develops. There are a couple different types of PGT. Oh, actually, let me say, oh, I think I'll cover that later. Okay, so different types of PGT. So one, and what we're mostly talking about today, is PGT-M. PGT-M, that stands for monogenic. So this is PGT for a specific genetic condition, a single gene disorder. And doing this, so when they do this, the biopsy and testing of the embryos, they are either doing direct testing of those cells to see if it has the variant, or they may do it through what's called linkage analysis, to basically to determine does that embryo have the normal or abnormal gene copies? What's their genotype? And this again allows selection of unaffected embryos to transfer and attempt a pregnancy. It's highly accurate. I think most PGT labs would quote around 95%, but it is still recommended to do confirmatory testing either during the pregnancy or postnatal, just to be sure. A caveat here is that PGT is not possible when the condition is de novo, when it's a de novo variant. So there's 2 other types of PGT. PGT-A, the A stands for aneuploidy, which is a fancy term that means extra or missing chromosomes. So you can do PGT-A either to screen for chromosome disorders like Down syndrome or other abnormal chromosomes that might impact the viability of the embryo, and you can use this for sex selection. So in the context of leukodystrophies, sometimes a couple, it might be an option or more appropriate to use this for an X-linked condition. So if we're talking about a male who is affected with an X-linked leukodystrophy, again, going to use ALD as an example. So that male, while he is not at risk to have a child affected with the condition, all of his daughters would be carriers. And so, so some men and couples might feel, I don't want to pass this on. I want it to stop here. Or I don't want to have a daughter, even if she's a carrier, who's at risk to develop symptoms. So they might use PGT, the PGT-A, to choose only male embryos. And then a female with an X-linked leukodystrophy could use it to choose only female embryos. This is, I think this is a scenario maybe if the exact gene variant or the exact genetic type of leukodystrophy isn't known, but it's clear that it's something on the X chromosome. So that's not ideal for testing of an embryo because you don't actually know, is that female or the male affected or not affected? And then the third type of PGT, which isn't relevant here, is called structural rearrangements. This would be if somebody carries a balanced change in their chromosomes, like 2 pieces of a chromosome broke off and switched places. But leukodystrophies are not generally caused by these sort of structural rearrangements, but I'm just mentioning it in case you are considering these options. That way you know what is the different terminology that's being used. So the main advantage or pro for PGT is that it allows you to select unaffected embryos before the pregnancy begins. And that would avoid the need for termination of pregnancy if that's what you would consider. It's highly accurate, but it's still recommended prenatal testing to confirm. A con is that you don't get to get pregnant the old-fashioned way. I don't like to say natural, I put that in quotes, because in my book, there's no unnatural pregnancy. There's no unnatural child. It's just using different methods of getting there. And you may need multiple rounds of IVF, and there isn't a guarantee of success. PGT is very expensive, but some insurance companies do cover it, and I think it's becoming more common for health insurance to cover PGT and IVF. So you should consult with your fertility center to learn, does your insurance cover it? What are the costs? What are the options? And there are resources for those who don't have insurance coverage for PGT. Just like you can finance a house, you can finance an IVF cycle. So now let's talk about prenatal testing. This refers to genetic testing during a pregnancy to determine if the fetus is affected. If it has for a recessive condition, if it has 2 abnormal gene copies, for an X-linked condition, what that genotype is. So this would allow the option to terminate the pregnancy if it is affected, or to prepare for the birth of an affected child. And there are 2 procedures to obtain cells or tissues from the fetus or the pregnancy for DNA testing. So chorionic villus sampling, or CVS, not the pharmacy, but the procedure. So CVS is performed at the end of the first trimester. So that's shown here on the left, where it's either done with a catheter through the cervix, or depending on the position of the placenta, a needle through the abdomen to take some of the placenta cells. That's called cells from the chorionic villi, which is sort of like the fingery projections from the placenta, because the DNA in the placenta is generally the same DNA that's in the fetus. And then amniocentesis is performed a little bit later in pregnancy, after 16 weeks. And this is a needle through the abdomen to take some of the amniotic fluid, which contains cells from the fetus. And then these cells can be sent for genetic testing. So prenatal testing is highly accurate, probably more accurate than PGT. There is a small risk of miscarriage associated with the procedures. It's less than 0.5%. And the earliest time you'd get results would be in the beginning of the 2nd trimester. And then, of course, the biggest con is that if the fetus is affected, we can't fix it. So that would be information to use to decide how to proceed. I want to take a minute to address non-invasive prenatal screening, delightfully referred to as NIPS, or cell-free DNA testing. This is what a lot of people think is the gender test, where it's a blood test performed around 10, 11 weeks that can tell if you're going to have a boy or a girl. So you can have one of those gender reveal parties, which is not the intention of the test, but I think that's how a lot of people hear about it. So NIPS is analysis of DNA chromosome fragments from the placenta that are circulating in the pregnant person's blood. So there actually is placenta and fetal DNA circulating in the mother's blood. That's why it's also called cell-free fetal DNA testing. And this is a blood test performed. It can be done as early as 10 weeks in pregnancy. Now, this is a screening test, and it's intended for screening for chromosome disorders like Down syndrome or other major chromosome disorders that's caused by a missing or extra chromosome. At this point in time, it cannot be used to test for single gene disorders such as leukodystrophies. There's a variety of technical reasons for that. There are several companies that are working on developing the ability to test for single gene disorders in this blood test, but currently it's not available. A couple or a person who has a leukodystrophy might use NIPS if they have an X-linked leukodystrophy. They may choose to do NIPS to determine, is the fetus a male or a female? And then only if the fetus is male would they proceed to do a CVS or amnio, with the thought process that if it's a female, she wouldn't be fully affected by the condition. But again, that goes back to the caveat that for some X-linked leukodystrophies, women can't show symptoms. And there's high accuracy for determining fetal sex, over 99%. But to be clear, can't test, it's not a diagnostic test for leukodystrophies. So now, moving away, we're going to talk about donor options. So this is using donor eggs or donor sperm, or you can receive a or use a donated embryo. So why might one choose a donor options? So it could be, so this could be used for an individual who is affected with an autosomal dominant or X-linked leukodystrophy, or couples who are both carriers. So for a person with an X-linked or dominant leukodystrophy, maybe PGT, the prenatal the PGT part of IVF is maybe not an option for them financially, or from an personal value standpoint. They could use donor eggs because that donor is not going to have that genetic condition. And same with using a donated sperm. For couples who are both carriers of an autosomal recessive leukodystrophy, using donor sperm, where the donor would have been tested in advance to make sure they're not a carrier, that would be a way to ensure as best possible that the offspring wouldn't be affected. Using a sperm donor is much less invasive than IVF, and it's also less expensive. So that's a reason why couples might choose it. And there could be other scenarios as well. And receipt of donated embryo, as we said, because that the donor parents, if you will, do not have the leukodystrophy. And last but very not least is the option of adoption. There I put here this website Resolve, or this page on the Resolve website, has lots of great information about what does that adoption process look like, the different types of adoption, like domestic or international adoption. So if this is something that you are considering, or I encourage really any couple who's considering using any of these reproductive options to also look into adoption. So that is the end of my informational slides. I have some resources here, but I intentionally wanted to leave plenty of time for questions and discussion, especially since we have a small group here. So